a video to help you through the activity on concentration units. Concentration describes the amount of solute in a solution. Please refer to your textbook and review the definitions of solute, solvent, and solution. There are many different concentration units that we will see, but all concentration units tell you the amount of solute per amount of solution. Here's a figure that shows you a range of different solutions that have different concentrations. Diluted solutions sometimes are also called weak solutions. They have fewer molecules of solute per amount of solution. In this case, the solute is a red dye. Notice that there's more and more red dye per amount of solvent as you go from left to right. The weaker solutions are said to be more dilute, or they are diluted, and the stronger solutions are said to be more concentrated. They have more solute per amount of solution. Let's learn about the concentration units that you'll need to know for this semester. One category of concentration unit are the parts per million and parts per billion. This literally translates as parts per million or parts per billion, and it tells you how many molecules of solute are in 1 million or 1 billion molecules of solution. These are one set of definitions that you can use to calculate parts per million or parts per billion. Another one is over here. If you remember that parts per million in an aqueous solution or in a solution of water is the same as milligrams of solute per liter of solution, then you can usually go through less unit conversion than if you have to convert all the way to million molecules of solution. And the same thing for parts per billion. If you can remember that parts per billion is the same as the units of micrograms of solute per liter of solution, sometimes the problems are easier to solve. If I were you, I would write these on your cheat sheet and use these to calculate parts per million or parts per billion. These are units that describe very dilute or very weak solutions. In the medical field, you'll often see these in blood or urine analyses, where you're detecting things that have very, very low concentrations. Another unit is molarity. Molarity is moles of solute per liter of solution. And you can also see this type of unit as millimolarity, which is simply millimoles of solute per liter of solution. Molarity is represented by a capital M, but it can also be written as moles per liter of solution. And millimolar is written as little m, capital M, and it can be literally read as millimoles of solute per liter of solution. And one can be converted to the other using the equivalency that 1 mole is equal to 1,000 millimoles. Since this is true, 1 molar is equal to 1,000 millimolar. A unit very closely related to millimolar is milliequivalence. An equivalent is an equivalent of charge. And so it basically tells you how many moles of charge are in a solution, or moles of ionic charge. You can refer to your textbook to understand the relationship between these, but we won't deal with them any further in this class. Anytime you're dealing with molarity or millimolarity, it's handy to know how to convert between moles and grams. Remember, the way that you convert between moles and grams is using the molecular weight, or the molecular mass, which can be calculated from the periodic table. If you need to review this information, please see the activity on moles. In the medical field, you'll often see units of millimolarity or even milliequivalence in electrolyte replacement IV solutions. Here are some examples. These are pictures of solutions that are directly injected into patients' veins. Notice the units of concentration are given in milliequivalence or millimolar. A percent composition is another type of unit. There are several different varieties of percent composition. M over M can also be represented as W over W. It just means the mass of solute, or the weight of solute, divided by the mass or weight of solution. And since it's a percent, it's times 100%. A volume over volume percent is volume in milliliters divided by volume of milliliters, solute over solution, times 100%. And M over V is grams or mass over volume or milliliters. Remember that the M for mass is sometimes represented by W for weight. Another useful form of these units is to use parts of solute per 100 parts of solution. I'll show you how to use this later in the video when I show you how to solve some problems. In the medical field, you'll often see these on IV bags and vials of drug solution. Here's an example where a concentration is given in a percent. In this case, it's not stated whether it's M over V, V over V, or M over M, but you could figure it out knowing a little bit about sodium bicarbonate. Here's another example. This is a barium sulfate solution. It's given in both mass over volume. In this case, the mass is represented by a W for weight. So it's represented in weight per volume and weight per weight, or mass per mass. And notice that those units are not exactly the same. So normally they're pretty close, but they're not exactly the same, and it's worth knowing what those units mean. Here's an example where it's 2% lidocaine solution. Once again, they don't give you whether it's mass over volume, but you might infer it from some other information that's on this container. Here's an example of a container that came from a foreign country. Some of our medicines are from other countries where the primary language is not English. That means that sometimes you'll need to use your knowledge of chemical formulas and of percents or other concentration units in order to understand the materials that are in this container. Sometimes this is very critical for giving the right dose to your patient. And here's some other labels. This is a 3% sodium chloride solution and a 50% dextrose solution. Sometimes you'll have the same type of solution, like this one, sodium chloride, but there are different concentration units. Does it make a difference? I'll tell you that the answer is yes. And I'll explain why in this particular situation it's critical to give the right concentration to a patient. Let's use another example right now though. We'll get back to this one later in the semester. Here are two bottles of heparin. One of them is meant for an infant and the other one is meant for an adult. It's very easy to mistake one of these for the other, especially when you're in a hurry and you're just grabbing a bottle off of the shelf. Unfortunately, sometimes patients get dosed with the wrong dose because bottles look similar. And often drug manufacturers try not to let this happen, but it's sometimes difficult. There are two examples I'd like to point out. In 2006, 6 babies at the Methodist Hospital in Indianapolis, so that's pretty close to us, were given the wrong dose of heparin, and 2 of them died. Why were they given the wrong dose? Well, here's a bottle for the infant, and here's a bottle for an adult. And the nurse accidentally grabbed the wrong bottle and gave the dose of a more concentrated solution to the infants. A more famous case was in 2007 when a nurse at a prestigious hospital in LA mistakenly did the same thing to Dennis Quaid's 12-year-old twins. This was more famous because the person involved was famous, and he sued the nurse and the hospital. His twins were given heparin 1,000 times the dose that they should have received. And although they are fine, they could have been killed by this. It's very important that when you grab a bottle of medicine off of a shelf that you check the units. It's very easy to get in the habit of just grabbing the bottle and not checking the label, but you can see how it can end very badly if you don't. The dose does matter, and the concentration matters too. It's not only important to grab the right bottle, but also to know what the concentration units mean so that you can calculate the right dose in the cases when you do need to calculate it. The concentration units that we'll be focusing on are on the page in front of you. Now I'm going to switch gears and solve some of the problems with you that are on your activity. It'll serve you well if you pause the video now and try to solve the problems on this activity by yourself before unpausing the video. Give it a shot and then I'll help you out. This is a video to help you through problem solving in the activity on concentration units. Remember that when we're dealing with concentration, we're always dealing with the amount of solute per unit of solution. The units that we use for solute and solution will depend on the unit of concentration we are looking for. Let's try the first problem. Notice that this problem is asking for the molarity of 750 milliliters of solution containing 2.25 moles of NaHCO3. Here, we can assume that the solute is the 2.25 moles of NaHCO3 and that the solution is given in this amount, 750 milliliters. Now, we need to use these units to find molarity. Molarity is represented with a capital M. Molarity is the unit of moles divided by liters, specifically moles of solute divided by liter of solution. Now, if we just start out by putting the solute amount on the top and dividing by the amount of solution that we've been given, this turns into a simple unit conversion problem. We already have moles of solute on the top, but we need to convert milliliters to liters. We can do this with a simple unit conversion, knowing that 1,000 milliliters is equal to 1 liter. Milliliters cancels out, and we get liters of solute on the bottom. The answer to this would be 3.0 moles per liter, which is the same as saying 3.0 molar. Now let's try the next one. Once again, this question is asking for molarity of a calcium chloride solution prepared by dissolving 145 grams of calcium chloride into a total volume of 2 liters. The solute amount is given in grams and the solution amount is given in liters. So once again, we're dealing with moles of solute over liters of solution. If we write the amount of solute over the amount of solution we have, once again, it turns into a simple unit conversion problem. We already have liters on the bottom, just like we need in the molarity concentration unit. But now we need to convert grams into moles. To do this, we need the molecular weight of calcium chloride. You would find the molecular weight of calcium chloride from adding the atomic mass of calcium to twice the atomic mass of chlorine. 1 mole of calcium chloride is equal to 110.98 grams. I can then use this as a unit conversion to convert grams of calcium chloride into moles of calcium chloride. Here I've written my calculator answer, and I would round this to 3 significant figures because I was limited by 3 significant figures based on my original information. The answer is 0.653 molar calcium chloride. In the third problem, it's asking me how many grams of sodium chloride that I will need to prepare 5 liters of a 154 millimolar electrolyte solution. 154 millimolars means that my solution is 154 millimoles per liter. Here, I've read the millimolar unit literally as millimoles per liter of solution. Another way to think of this problem is as a conversion from 5 liters of solution to the number of grams of solute I will need. In this case, I'm actually finding the grams of solute I will need to make a total amount of solution if I am given its concentration. To do this, I will take the amount of solution I need to make and I will convert it into grams. I can use the solution concentration as a unit conversion between liters and millimoles. To convert between millimoles and grams, I will need the molecular mass of sodium chloride. First, I will convert from millimoles to moles, and then I will convert from moles to grams. This will leave me with units of grams. And I will round to 3 significant figures since my answer is limited to 3 significant figures. In the fourth question, it is asking me to calculate the concentration in percent M over V. There are 2 main ways that people think about percents. One is the amount of solute over 100 units of solution. In this case, because we're dealing with percent in M over V, it's mass in grams over volume in milliliters. So this would be grams per 100 milliliters of solution. Most often, it is reported as a percent, which means that it's in units of grams per milliliter times 100%. I will use the second part to actually calculate the percent M over V for this particular solution. Here, my solute is 5 grams of sodium chloride, and the amount of solution is 400 milliliters. I'm already in the correct units of grams per milliliter, and the only thing I'll have to do to get a percent is multiply by 100%. The answer should be given in 2 significant figures, since I was limited to 2 significant figures by the 5.0 grams. I round down because my exact calculator answer was 1.25, and when I have to round to one place and the next digit is exactly 5, you round down. In number 5, I'm trying to find the concentration in parts per million. It's useful to remember that parts per million is the same as milligrams of solute divided by liters of solution. This is the same as 1 part of solute per 1 million parts of aqueous solution. In this case, my solute is glucose and my solution is 125 milliliters. If I write the amount of solute over the amount of solution, now it turns into a simple unit conversion. I need to convert grams of solute into milligrams of solute, and then milliliters of solution into liters of solution. This gives me the answer of 1,240 parts per million of glucose solution in 3 significant figures. In number 6, I'm asked for the grams of my solute, glucose, that are present in 750 milliliters of a 5% M over V glucose solution. First, it's useful to rewrite the 5% M over V glucose into units that are useful for unit conversions. 5.0% M over V glucose is the same as saying 5.0 grams of glucose divided by 100 milliliters of glucose solution. This is a more useful form for doing a unit conversion because I can see that I'm going to be converting my 750 milliliters of solution into grams, and my concentration is the way to get there. Grams of glucose is what I'm looking for, and the milliliters of solution is what I am converting. Doing this conversion, I get my answer in 2 significant figures to be 38 grams of glucose. Number 7 asks how you could prepare a 0.90% M over V sodium chloride solution using 1 liter of water. What it's asking is for how much sodium chloride you would add to 1 liter of water to make this solution. In other words, how many grams of sodium chloride are in 1 liter of this solution? So once again, we're going to be using concentration as a unit conversion from liters to grams. It's useful to rewrite the concentration unit in a way that can be useful for a unit conversion. 0.90% M over V could also be written as 0.90 grams of NaCl divided by 100 milliliters of solution. Now it is a matter of converting liters into grams. The answer to 2 significant figures is 9.0 grams of sodium chloride. So the answer to this question is that you would add 9 grams of sodium chloride and fill the container to 1 liter to make 1 liter of 0.90% M over V sodium chloride solution. Number 8 tells you that a healthy concentration of cholesterol in the blood is below 200 milligrams per deciliter. You might already know that a deciliter is 100 milliliters. The problem is asking you to find this concentration in a percent M over V. Remember that percent M over V is in grams per milliliter and can be thought of as grams per 100 milliliters or in grams per milliliter times 100%. I'll rewrite the units as given, 200 milligrams per 1 deciliter. Now this is simply a unit conversion problem. I need to convert milligrams into grams, and then I need to convert deciliters into milliliters. If I solve this problem as written, I would get the answer in unit of grams per milliliter. To be thorough and turn this into a percent, I will have to multiply by 100%. My answer should be 0.2% m over v of cholesterol. So you could also say that a healthy concentration of cholesterol in the blood is below 0.2% m over v. Please try to apply what we've learned here to the Check for Understanding problems. The key is available and you should check your work to make sure you're correct. If you have any questions, feel free to post them in the comments and please let me know if this video was helpful.